Problem 18. Discuss the continuity of the function below. In your discussion, include the words removable, non-removable, vertical asymptote, horizontal asymptote, and whole. The first thing that I'm going to concentrate on are those vertical asymptotes and wholes. So I know that I'm looking for where would the denominator equal 0. The first thing that I'm going to do is go ahead and factor the denominator. So I've got x plus 1, x minus 2. From here, I know that where that denominator would equal 0 would be at x equals -1 and x equals 2. I do also notice that my x minus 2's will cancel out. So in my discussion, I would first of all say, I'll discuss x equals -1 first. I would say the vertical asymptote is x equals -1, and the reason that it's a vertical asymptote is because it is a non-removable discontinuity. It cannot be canceled out of the problem. Okay, the next discussion I would have is about x equals 2. X equals 2 would be a whole, so I'd say there is a whole at x equals 2, and that would be because it is a removable discontinuity. I was able to cancel it out of the problem, so it's easily plugged. Okay, the next discussion that I'm going to have, let's see, I've used the word removable, I've used the word non-removable, I've used the word vertical asymptote, I've used the word whole. The only thing I haven't discussed is the horizontal asymptote. I know we find horizontal asymptotes by finding the limit as x approaches infinity, so I will do that. Just rewrite my function here. And remember, when we're finding the limit as x approaches infinity, I'm comparing the degrees in the problem. The degree of this one would be a 1, and the degree of this one is 2. So I notice that the degree in the numerator is less than the degree in the denominator, and when that happens, my limit will equal 0. So the limit on this answer is 0, and since the limit as x approaches infinity is 0, we've got a horizontal asymptote. So I would say the horizontal asymptote is y equals 0, and the reason that it's a horizontal asymptote is because the limit as x approaches infinity is equal to 0.